If you haven't read the three articles that go before this, I would stop now and just go back and do those three readings. They're quite short, and there's quizzes to go with each of them. If you have finished them, welcome to investigating why clouds produce rain. So in Galetown, we're realizing that there's an increase in severe uh, weather storm and rainstorms, severe rainstorms. So we're going to look at why clouds produce rain and what factors lead up to, what sequence of events lead up to that. To get started, turn to page 24 in your book. You're going to see that there are three questions. What happens when water vapor cools? And it says check all that apply, which would indicate that there's more than one right answer. Then the next question is the energy that transfers out of an air parcel to form clouds originally comes from. So we're looking for the origination, the origin of the energy. Sorry. Notice that the clouds of different sizes in the photos below. In which photo do you think the most cooling energy transfer occurred to form the clouds? Press pause to answer these three questions, and when you're ready, join back in. All right, so welcome back. So for question one, it says, what happens when the water vapor cools? We know from the other previous lessons that the water goes from a gas phase into the atmosphere, and as it goes up, the air around the water vapor gets colder. As it gets colder, it changes back into liquid. This is what we call condensation. So A is correct. It becomes a liquid. B says it stays the same. If we know it changes to a liquid, it can't possibly stay the same. Then C says energy transfer. We know that as things change, it requires energy to make something change or move. So we know that there's going to be some type of energy change. So C is also correct. And D, clouds form. This is actually the point of when a cloud forms. As it goes from water vapor back and cools off, it becomes a liquid. That is condensation. So question two asks you about the energy and where does it come from. We know that the energy comes originally when the water is heated by the sun to go into the water vapor phase. So the origin is the sun. And as it goes into, then it transfers and changes. Goes into the atmosphere, sorry. Notice the clouds of different sizes in the photos below. So if we look at the pictures, A is significantly larger, B almost none, and C looks like a standard individual, a cute cloud. But if we look at A, there is a lot. If we know that energy transfer is what causes clouds, if there's a lot more cloud, that means there would be a lot more energy transferring. So what is a cloud? A cloud is liquid water droplets suspended in the air. So this is the point at which the cloud is already turned back into liquid, and it is now hanging out in the air. When you were in the younger grades, they might have done an experiment where they took water and they took a sponge and they soaked up the sponge. If you put a little bit of water, nothing really happens. It just stays in the sponge. But as you increase the water, it starts to drip out, almost like it's too heavy. And this is very similar. This is actually a really good model for clouds, because what happens with the clouds is that it goes from the gas phase as water vapor into the sky. And as it gets into the sky, it cools off and goes back to liquid. As it's in the liquid phase, which is the condensation, it is the cloud. Now, at this point, it's waiting for gravity to pull it down. You read in the articles that that gravity pulls the rain or the water back down. So it has to reach a certain amount of weight or a certain amount for it to really get gravity to pull the liquid back down. So if we look back at our investigation question, what causes an air partial to cool? So when does it become a cloud? Is another way to ask this question. So when does it become a cloud? It becomes a cloud when there is enough water vapor that turns back into liquid. Now, but what causes this to happen? So I want you to look back at the article, What Are Clouds? Now, you don't have to go and pull up the article. I pulled up the portion that I'm really interested in, and it's the last excerpt on the bottom of the article, and it's called Cloud Formation and Energy. Now, if you need to pause just to reread this section, go ahead and do so, but I'm going to be moving on to this section right here. The last couple sentences here. The more energy an air partial loses, the more it cools and the more liquid water it forms, making more rainfall possible. So this right here is very important. The more energy the partial loses. And the kind of energy we're looking at here is going to be heat energy. It's going to be temperature. Because when we're measuring the energies that it has to do with the thermal energy, which is why it's very important that you kind of try to look back at your notes for thermal energy. So we're going to actually run this idea in the simulator. So you can actually either follow along on a separate device, or you can pause and go back to the simulator at any time. If you can't access the simulator on Amplify, I'm going to be doing the entire experiment here in the video. So I'm going to, let me see if I can pull this down without exiting out. Sorry, guys. There we go. So up here I have the simulator, which is in the original form that it comes in when you open it. And I also have the chart that's located on page 24 for you. So if you want to page 26. Please look at page 26 for this. Now, we're trying to see the energy changing and how that can affect how much rain. Now, on the side here, it has levels 1 and 2, no rain, level 0, and then levels 3 and 4, which would indicate severe storm. I'm going to go into here and I'm going to change some of the settings. I'm going to change the air temperature on the outside to 20 degrees, negative 20. If I can get it, perfect. Negative 20. Oh, not yet, not quite. There we go, negative 20. And then the air partial. So this area right here would be the air vapor that's coming up. So this is the temperature in the sky. Negative 20 is below freezing. It's in Celsius, keep that in mind. I'm going to turn this to 25, which is is kind of warm. It's quite warm. So we have these two different temperatures. One is much warmer than the other. And I'm going to turn the water vapor into medium high. So I'm going to run this. So before I do that, I want to put the temperatures in. And I'm going to put, so let's wait till the end. As you can see, the energy is going out. And we do have some rain. Note that the energy is going out because it is going from the hotter to the colder, which we learned in thermal energy. So let's take a look at what happened here and how we can fill it in on our chart. Here we have it at a rainfall of 1, which is mild, which is a standard rainfall. The starting surrounding air that we started at was negative 20 degrees Celsius. And the air vapor, or the partial of air that was coming into that atmosphere, was 25 degrees positive. The final air was negative 20. It makes sense that the air would turn to the temperature on the outside, since the outside atmosphere has way more air. And as remember, with thermal energy, the total number does matter. Now, let's look at the difference. The difference between the starting and final was 45 degrees. It changed from negative 20 to 25, which is a difference of 45. And the amount of energy that transferred out was 99. This gave us a rainfall of 1 to 2. Now, if you want to try on your own to get level 0 and levels 3 or 4, you're welcome to do so. If you don't have the option to do that, you can follow along. Now, I'm going to go to the build. I know that for there to be, according to our article here, the more energy that the air partial loses, the more it cools and the more liquid. Now I'm looking for less liquid. So I don't want there to be much of an energy loss. So I want there to be a similar energy difference. So what I'm going to do is make the outside air quite similar to the partial of air that's coming up as water vapor. So we have negative 1 and 7, which is a very small difference. So I'm going to run this. The energy is still going out until it equals the same thing. Now, I need to check to make sure that I indeed had 0 rainfall. So because the difference in energy was very small, only 8 degrees difference, it lowered my rainfall. So I'm going to add that data in there, that the outside was negative 1, the starting was 7, it ended at negative 1 with a difference of 8, and the energy was also 8. So keep this in mind here, guys, that as the difference, when it gets high, it has more rain. When it's low, it has less rain. So let's take a look at if I want to have a severe storm, a very dramatic storm. I'm going to want to make these as different as possible. Now, this kind of supports claim 2 with the warmer weather. But also keep in mind, it also might support claim 1. If you look at my water vapor, it's very much indicating that we're on the higher end. And we do remember that there is a lake option. So I just want you to keep that in mind. All right. So I'm running this with the really dramatic differences. And as you can see, it's definitely causing a great storm. Now, let's take a look at the numbers. So we started with negative 40. And the air partial was much warmer at 40. Negative 40 to 40 is a difference of 80. And the final temperature was negative 40. It copied the outside temperature. And how much energy was transferred out? 185. So all of this thermal energy is being transferred out. So the more thermal energy that is released, the greater the storm. This was labeled as a severe storm. I'm going to stop there. can go back to the slideshow. So you can take this data down, pause on it if you need to stop to put it down on page 26 and 27. All right, so now we're back at our slideshow, and we have this key concept that energy transfers from warm air to cold air until the temperature becomes equal. We know this from the thermal energy unit, that they want to get to almost an equilibrium. They want to get to the same temperature. Then we have the concept from the article that says the more an air parcel loses energy and cools, the more rainfall it can happen. So when there's a dramatic difference between the outside and inside temperature, we see a much heavier rainfall. Now, this is supporting claim 2, that the increase in temperature would increase the severity of the storm, because the groundwater vapor would be much hotter going into the atmosphere at a hotter temperature than it was before. Now, just because something supports claim 1 doesn't mean that the other claims are not true. So for homework, I want you guys to look at the homework on page, let me just make sure I get the right page for you guys. I believe it's page 28 for you guys. If you look at page 28, in your book here, it asks you to measure keeping the outside temperature at 25, the outside temperature at 25, and the air partial at 35. So what we're doing now is we're kind of not talking about temperature anymore, but we're going to talk about the water vapor. So we know that dramatic differences in temperature would cause a more severe storm. But we also want to test theory 1, claim 1, which is the amount of water. So I want you to run the test on low, medium, and high. We know that there's always water vapor in the air, but we want to test it on a low number, a medium, and high. High indicating being similar to adding the lake, and low being without the lake. So running it with the same temperature on the outside, same temperature on the inside, and then changing the amount of water. Seeing if that would change any part of the system, change any of the levels of severity of the rainstorm. So I want you guys to do that. And then on Google, after you watch this video, I'm going to put 2 questions for you to answer. It's going to be this question, question 2, and then another question to go along with this video to see how much you guys are understanding. If you guys have any suggestions for me to change this video up to make it a little more interesting, please let me know. I know that Lady London Sprinkles hasn't made her appearance yet, but she will be doing that soon. Have a good day, guys.